the sort of performance characteristics of TensorFlow.js is like maybe a quarter of what, 4 times slower than what you can do with native CUDA and Python stuff, but still it's good performance. So I'm not betting, but I'm sticking a lot of my energy and effort into this future direction. I would say 80% of my time right now I'm actually focusing on learning TensorFlow, also learning machine learning. And the kind of cool thing is there's a sort of motivation for me there to learn this stuff. A lot of times when you're at school and you're trying to learn about mathematics, it's kind of really boring and dry because you're not seeing any practical use for it. So what I'm doing is I'm learning this machine learning course, and I'm also playing around with TensorFlow.js on a sort of higher level to see what I can do. And then I get to a concept I don't understand, and then that motivates me to go back and look at the maths and Wikipedia. Now, a word of warning, when you start looking at some of these terms, machine learning, and you go into Wikipedia, you can really quickly get into 20-tab rabbit hole deep of terms, and you still, it's like looking at a fractal. All these terms, you can go down and down, 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 and down. But for me, it's really stimulating. So now there's good news and bad news here for you guys. You guys are probably a lot weaker at maths compared to the people that are doing machine learning at the moment. But you guys' JavaScript experience and application development gives you a much bigger advantage than those guys. So all those people that are sort of wanting to get into the web from Python, they don't have to relearn how to do JavaScript and application development. You guys, if you want to get into this stuff, you have to look at the maths, and it is going to be hard if you guys want to. You can't just casually get into this stuff. You have to think, okay, 1 night a week or 3 nights a week for an hour. You have to sort of, it's like throwing rough cast at a wall. Some stick, some doesn't. So in order to actually help me in my learning process in this whole deep learn journey, I created a Discord server for it. And actually 4 people on Google have actually joined the server. So this is a Discord server I created for TensorFlow.js. And there's kind of interesting discussions going on because there's a lot of these concepts and stuff that's kind of tricky. But yeah, there's probably a link in the meetup about this Discord server. This is the TensorFlow.js website. There are some interesting examples out there. They're kind of high level, and there's a lot of advanced concepts in them that would take you a few months to figure out what's actually going on at a lower level. But the library itself is kind of high level. A lot of the algorithms and stuff for machine learning and for various types of artificial intelligence applications are built into the library. And they're becoming more and more like the Python version of TensorFlow.js. So for example, Python has support for inverting a matrix, whereas the JavaScript one doesn't have that yet. And what the library actually does, it has, you can do all the stuff in the CPU as well as the GPU, and they have a library that manages all the calculations on the GPU. And the code is kind of hairy because it's the actual library, TensorFlow.js, is having to manage a lot of low-level details and operations on the GPU, translated sort of from JavaScript. And what it does internally is it has a big string builder, and it builds up shader programs, a mixture of things like that, and gets stuff done on the GPU. But anyway, a lot of that stuff can be hidden from you, and you can do, as long as you understand the mathematics and the models, you can do machine learning applications in the browser running on the GPU. They're also working on Node.js support, so you can run the same calculations on the GPU, but you can run all the CPU stuff on the node, but not the GPU yet. So the tutorials are actually really, really well written. The ones in DeepLearn.js were not quite as good as these ones, but they've done a really good job here. And there's quite a few Google employees that are working on this library. I created one just to play around for different things. The deep learning examples were using Browserify or something like that, but I don't like using Browserify. I like using Webpack. So I took one of their examples to test for a quadratic equation and wrote a Webpack way to import it. And I used TypeScript. So before the DeepLearn library, in a few months, nobody actually ever know it was actually called DeepLearn.js. Nobody will care. But just to give you guys a little bit of history, because there's a bit of history with me, you guys, and DeepLearn.js. Before, the library was called DeepLearn, and everything was under the namespace DL dot whatever it was. And then now the new library, it's TensorFlow, and the import is now it's actually split up into 7 npm modules. So it's at TensorFlow, and what I just replaced to get the new TensorFlow one versus the DeepLearn one, I just replaced DL with TF, and then you can use all the library features. So just to give you an example of what a typical machine learning thing looks like in TensorFlow, I'll just take you through the first tutorial here and explain what it's doing. So I'm sort of going to skip this bit here, but the low-level building blocks of what tensors are these things called tensors, which are basically multi-dimensional arrays, and they're immutable. So they've went immutable straight out of the box. And then so a typical problem in machine learning is trying to find patterns to things, whether it's be classifying images or, in this example, fitting a quadratic equation, ax squared plus bx plus c. Do anyone remember that from high school? Does anyone know what a quadratic equation is? So you basically got a y-axis and an x-axis, and you draw a line, a squiggly line. So, for example, this is what I mean. This is not a high-performance application. This is just like the CPU could run this no problem. This training example, but it's just to show you kind of at a high level what the library does. I'll just close on my Bitcoin share prices up here. I can't see anyway. Today was a bit of a wild one for Bitcoin, by the way. So here I have a chart that we know is an ax squared plus bx plus c. That's typically more than what you know if you're looking at using machine learning in a real-world application, but this is just to simplify things. So we've got all these points here, and what we want to do is we want to train our machine learning program with the real data on what the constants are for that equation, so a, b, and c for the quadratic equation. So what you do if TensorFlow here is you create these variables, and these are immutable variables, and they're sort of magically updated while you train the model. And you do all this in JavaScript. So these are you create these variables in JavaScript, and these will be used throughout the application in this as you train it. And the way that you train the application is you create this thing called a prediction function and a loss function. So what we do here is this is a prediction. So it takes in a value, and then it multiplies it by the constants here, and they're initialized at random at start. So, for example, this will be a, b, c with a random number, and the reason that we have to wrap it inside this TensorFlow scalar thing is that we converts it to a tensor, and tensor is the thing that TensorFlow manages in the GPU and all that kind of stuff for you. So all these things that are tensors are sort of running in the GPU because of much quicker. And this prediction function takes in a value and then multiplies this tensor operations. All these operations are done on GPU or CPU, depending on whether you specify it to run on the CPU or the CPU is not available. And it gives you an output value. And then what it does in the tutorial, if you run it on your laptop, it will plot the line. So for this one, it's not been trained. It'll give you a line that doesn't fit the data, like that. And then you go into this, what's training the models. So you have to create 3 different things. A loss function, which compares the actual value versus predicted value. And then you create an optimizer function, which then changes the variables in a certain way. In this case, it's called gradient descent. It's a term that you would get onto in week 2 of the machine learning course. It's the free one. Gradient descent, basically what it is that it tries to find a point where your error function gets the lowest point, and it says that's the value. And it can work for as much dimensions as you want. So they have this statistics sort of stuff where you find quite commonly, a lot of the stuff in TensorFlow is they use normal patterns within machine learning, and those patterns are the same whether it's Python, JavaScript, or whatever. It's just there's a lot of research papers that have been taken. There's decades and decades of research that have basically come up with a lot of these things. So you have this loss function which compares predictions to the values from your model, and then you have this optimizer function. In this case, for this example, we're using something called gradient descent or stochastic gradient descent, and then you have a training loop. So you have this thing training in the browser for like 5 seconds or something like that, and it keeps adjusting the values of the variables until it finds the loss function has reached a minimum, and it says this is the coefficients of the equation. That's the simplest example, basically, there is for machine learning. The later examples in this go on to images and how to look at a number and how to classify a handwriting number into an actual letter. I'm still learning how that works, but it's a lot of stuff to do with convolution. There's some good videos on YouTube that explain what convolution does. And in a nutshell, what it does is it looks for patterns within letters. And from what I understand is it sort of groups these patterns and gives you a probability of what number that handwriting was. But like I say, it's kind of new stuff. I've been doing web development for 10 years. But it's refreshing, because I want to be, people, you go to a lot of these conferences, they're not really talking too excited about, web development, stuff like that. It's all AI, so I want to be part of that future. And that's why I'm investing a lot of time in this stuff. So anyway, in this case here, you have this is what it's training it. So you have the real values of x and the real values of y, and then, but you don't know what the the variables are. And what happens here is in this optimizer function, you check the loss of the equation above, and it adjusts the variables for. Is this making sense? It's not easy. So anyway, once you train this thing, you end up with coefficients that minimize the loss function for the quadratic equation, and actually it will find out the constants for you. That's really what I really wanted to talk about. But